All right, today we're going to dive into a really fascinating tool for predicting the future. But here's the twist. It works by completely forgetting the past.
Sounds weird, right? Well, let's get into the world of Markov chains.
I mean, that sounds totally backward, doesn't it? We're always told, learn from history, remember your past. But what if some of the best predictions we can make actually come from ignoring all of that? That's the exact puzzle we're going to piece together today.
You see, the whole secret hinges on this one idea, focusing only on the present moment. We're looking at systems where the future depends solely on what's happening right now, not the long, messy history that led up to this point.
So, this memoryless concept isn't just some quirky thought experiment. No, it's the actual engine inside a powerful predictive machine, and it has a formal name. And this is it. This is the big idea, the Markov property. What it's saying is to predict what a system is going to do next, all you need to know is its state at this very moment. It doesn't matter if it took one simple step or a million complicated turns to get here. All that history, it's irrelevant for the next move.
So how do we actually build one of these memoryless predictors? Well, it really just boils down to two super simple building blocks, states and transitions. First up, we need states, and a state is just a fancy word for a specific situation or a condition. Think of it as a status update. So for a really simple weather model, the states could just be sunny or cloudy. It's a snapshot of right now.
And then we have transitions. That's just the action, right? The jump from one state to another. But, and this is key, it's not just random. Every single possible jump has a specific, calculated probability of happening.
And this diagram just lays it all out beautifully. You see the two boxes? Those are our states, sunny and cloudy. The arrows show the transitions between them, and the number on each arrow, that's the probability. So, for example, that arrow looping from sunny back to itself has an 8.0 on it. That just means there's an 80% chance that a sunny day will be followed by another sunny day. Simple as that.
Okay, diagrams are great for wrapping your head around an idea. But to make this thing work like a real machine, we need to organize all this info. And that's where we build something called the transition matrix.
You can think of the transition matrix as the rule book, or maybe the brain, of our whole operation. It's basically a simple grid that neatly organizes every single probability for moving from any state to any other state. It's our ultimate cheat sheet.
And this slide right here perfectly connects the dots. On the left, you've got the visual diagram with its circles and arrows. On the right, you've got the math in a grid. They're just two ways of showing the exact same information. Every arrow on the left corresponds to one specific number on the right. See that arrow from state 1 to state 2 with a probability of 0.28? Well, you can find that exact same number where row 1 meets column 2 in the matrix.
Okay, theory time is over. We've got the concepts down. Now for the really fun part. Let's use our new tool to actually make a prediction.
So let's go back to our simple weather example. We know that if it's sunny today, there's an 80% chance it's going to be sunny again tomorrow. So the question is, what's the chance that it'll be cloudy instead? Let's use our model to figure that out.
And the process is incredibly straightforward. It's really just 3 steps. First, we define our states, which we've already done, sunny and cloudy. Then we figure out all the transition probabilities from our data. And finally, we just plug those numbers right into our transition matrix.
And here is the payoff. Look at the matrix. To find out the weather for tomorrow, we just start with today's state. So if today is sunny, we look at the first row. And the matrix just tells us, plain as day, there's a 0.8 probability of it being sunny again, which means there has to be a 0.2 or 20% probability of it being cloudy. The answer is right there in the grid.
Now, this might seem like a neat little trick for predicting the weather, but this exact same logic is running behind the scenes in some incredibly complex and important systems all around you.
What makes Markov chains so incredibly powerful is that if you let them run for a while, many of them eventually settle into this predictable long-term balance. It's called a steady state. And what that means is we can predict not just the next step, but the long-run behavior of the entire system, where things are likely to end up on average.
And honestly, they are everywhere. Businesses use them to predict if customers are going to switch brands. Engineers use them to model when computer parts might fail. They're even used to analyze things like the probability of a tax audit or to make sense of incredibly complex weather patterns. From economics to computing, this memoryless machine is a total powerhouse.
So once you realize that you can often predict the future just by looking at the present, you kind of start seeing these patterns everywhere. So I'll leave you with this question to think about. How many of the complex systems in your world are secretly just a simple, memoryless process in disguise?